Welcome to Math 31. This is a continuation of the lesson on the Fundamental Theorem of Calculus. So all I'm going to do is some more area questions and then a few other just straight evaluate definite integral type problems. So nothing really new, but going to be looking at things a little bit differently just to make sure that we're clear on some very critical points. So to start off with, taking a look at this cubic function, negative x cubed looks like plus 2x squared. Question then goes on to say find the total area between x equals 0 and x equals 4. So what you'll notice first off about this question is that x equals 4 is down here, of course, or leads us down there, but that we're dealing with a section that is above the x-axis and then a section that is below the x-axis. Now there's implications with this, so the main thing is for us to be really clear on what's going to happen and how we proceed with a problem like this. We cannot do it directly from 0 to 4. Now if you did that, and I will do that actually afterward just for purposes of comparison, but you have to make sense of your answer. Now what I'm going to do then, the total area to me implies that we are not going to deal with any negative values or anything like that. Rather, we're going to be dealing with just straight total area, absolute value area. Because if we called this area up top A1, A1 is going to be positive. Because the way we have these things set up, we're always dealing with the values above the x-axis. So the area above the x-axis is positive. What we've been dealing with so far. So therefore A1 is greater than 0. The area below the x-axis, so if we called this A2, is negative. So in this case, A2 is less than 0. And if we just went from 0 to 4, our calculator, or us, we would get probably a negative answer, because you can see by inspection at least that A2 occupies a bigger area than does A1. So I want to be careful with this one. To get the total area, I want to get the absolute value of A1, which is positive anyways by inspection, plus the absolute value of A2. So it's all in the way the question is worded. So therefore, A1 is from 0 to 2, A2 is from 2 to 4. And then we basically have adder. So I'm going to write this one out. A2, or AT, excuse me, is equal to the definite integral from 0 to 2 of the function negative x cubed plus 2x squared dx plus the definite integral from 2 lower limit to 4 negative x cubed plus 2x squared dx. Now, in order to do that, because this is going to turn into such a long question, I'm going to break it down and do A1 and A2 separately, and then put them back together again. So we're going to get some space. Oops. So A1, oops, what's going on here? A1 so the definite integral from 0 to 2, negative x cubed plus 2x squared dx. When we get the antiderivative of this, we're going to get x to the 4, and then negative 1 over 4 x to the 4 plus x to the 3 and then 2 over 3. And then we take this, so put the big old brackets around it, from upper limit 2, lower limit 0. And with care, we substitute the values in. So we get negative 1 over 4, 2 to the 4, plus 2 over 3, 2 to the 3, minus negative 1 over 4, 0 to the 4, plus 2 over 3, 0 to the 3. Now you could do this one on your calculator pretty quickly if you want, or you can just muscle your way through with the fractions. 2 to the 4 is 16. 16 divided by negative times negative 1/4, negative 4. And then 2/3 times 8, and then minus 0, because both of these terms basically go away. So negative 4 plus 16 divided by 3 is going to be equal to 4 over 3. And then when you go after A2, note that this is from 2 to 4. Same function, negative x cubed plus 2x squared dx. So this is going to become negative 1 over 4 x to the 4 plus the same thing, 2/3 x to the 3 from 2 up to 4. And we replace in the 4, so negative 1, 4 times 4 to the 4, plus 2/3, 4 cubed, and then minus the 2 substituted in, so negative 1/4, 2 to the 4, plus 2 over 3 times 2 cubed. And of course you'll know that that second part is going to be equal to what we had before on the previous. So I know that'll be 4 over 3. Now I work this first one out. 4 to the 4 divided by 4 is going to be negative 64. And then 4 cubed is 64 times 2 is 128 over 3. So negative 64. By the way, these are all, I should say that these are both going to be absolute values. Before I forget, I'll keep that there. So the absolute value of 4/3 is equal to 4/3. Not an issue in that first one, but here it does matter. So negative 64 plus 128 divided by 3, and then minus 4 divided by 3. And when you turn that into a fraction, or keep it in a fractional form, it becomes negative 68 over 3. But the absolute value of that, which is 68 over 3, so AT is equal to A1 plus A2. So the total area would be 4/3 plus 68/3. So AT is equal to 72 over 3, which is 24 square units. Now, had you done this on your calculator, just for inspection purposes, had you done it from 0 to 4, negative x cubed plus 2x squared dx, let's see what we get. So y1 is equal to that function, negative x cubed plus 2x squared. So negative x to the exponent of 3 plus 2x squared. Now, I don't think this is going to shock anybody. Notice I'm taking it from 0 to 4, so this is not the, really the answer we want, obviously, but do it anyways, upper limit of 4. Shades it in nicely on your calculator, and then when you do the fraction, you're going to get, this is equal to negative 64 over 3. And all that they did on the calculator is they went the total area. They did not calculate the, or consider the absolute value. They just went positive 4/3 plus negative 68 over 3 equals negative 64 over 3. So be careful with the calculator. It will do a great job, but it's limited in that it recognizes that A1 is positive and that A2 is negative, so it just adds them together, and then you're going to get a negative answer. You could have broken it into two sections, of course, in your calculator, 0 to 2 and then 2 to 4, but you would also have had the negative. You'd have had to make sure you adjusted it yourself. So something to be aware of. Now this next question is same sort of thing, except as we've been dealing with, but a trig function. So the area between the function cos 2x and the x-axis given these two endpoints. So negative pi over 8, so we're not going all the way to the very end, we're just going to right there. So we're not doing x-intercept to x-intercept. Now we do this exactly the same way we've done everything. Really what we're looking for is the definite integral with a lower limit of negative pi over 8 with an upper limit of pi over 4, and then the function itself is cosine 2x. And keeping in mind always with these that the antiderivative of the given function produces the area function. So when we do this, be careful because this is going to, I'll take it right down there, get some space. This is going to give you the antiderivative of cos 2x, the antiderivative of cos is sine 2x, but then you also have to have that factor of 1 over 2 in front. And keeping in mind as well that, always do a quick check because it's easy to make a mistake on the sign for these ones, but the antiderivative of cos is positive sine. And we will be taking this from the limits that are given, negative pi over 8 to pi over 4. So I'm going to get a bit more space and work this one out. But we substitute in the pi over 4 first off. So 1 over 2 sine of 2 times pi over 4 minus 1 over 2 sine 2 times negative pi over 8. Now we would certainly expect a positive answer in this case because we can see by inspection of the graph that we are above the x-axis. So this is then 1/2 sine of 2 pi over 4, which is pi over 2, minus 1/2 sine, well, 2 pi over 8 is pi over 4, so this is negative pi over 4. Now you could use an identity if you wanted to clean that one up, but it may not be necessary. So the sine of pi over 2 is 1, so 1/2 times 1 minus, now 1/2, the sine of negative pi over 4, that's the sine of 7 pi over 4. It's going to be negative because you're in quadrant 4, and it'll give you negative root 2 over 2. So that's a 45-degree angle. So we get 1/2 minus negative root 2 over 4. So 1/2 plus root 2 over 4 will give you, with a common denominator of 4, this would be 2 over 4 plus root 2 over 4. So it works out pretty nicely. Let's now turn our attention to just some straight, regular, definite integrals. So evaluate the following. So this trig function from pi over 8 to pi over 4. Now, if you graph this, you'd have an idea of whether you're above the x-axis or below the x-axis. I don't care. I'm going to do it strictly according to the instructions. Evaluate the definite integral. So you could get a negative answer. If the majority of this function is below the x-axis, we'll get a negative answer. And even if it's crossing several times. So you follow the instructions. If it's just a straight definite integral, you go wherever it takes you. And by the way, this is a good one if you want to do it on your own. Please do so. When we anti-differentiate sine of 2x, be careful, because the antiderivative of sine 2x is going to be negative 1 over 2 cos 2x. And if you're not sure that that's correct, just differentiate cos 2x, or negative 1 over 2. And remember, the derivative of cos is negative sine. So we're okay. And then the antiderivative of cos 2x, we kind of saw this one earlier. It's 1/2 cos 2x. Taking this from pi over 8 down below to pi over 4 up top. Carefully get the substitution made. Negative 1/2 the cosine of 2 times pi over 4 plus 1/2 cosine, this should be, this should be 1/2 sine. You're wondering, where did that come from? So, okay, let's fix this up before the damage is permanent. Sine of 2 times pi over 4. It's the thing, when you do these recordings like this, you make a mistake. You may never find it, whereas do that in front of a bunch of people in a classroom, they'll start hollering at you. So this is negative 1/2 cosine of 2 times the lower limit, pi over 8, plus 1/2 times the sine of 2 times pi over 8. So we make sure everything is okay. Looks like we have it. Pi over 4, pi over 4, pi over 8, pi over 8. Okay, so now we get negative 1 over 2 times the cosine of 2 pi over 4, which is pi over 2, plus 1/2 times the sine of pi over 2, minus negative 1/2 times the cosine of pi over 4, plus 1/2 times the sine of pi over 4. So cos of pi over 2 is 0, plus 1/2 sine of pi over 2. We just saw that earlier. That's just 1. And then here, cosine of pi over 4 is negative 1/2 times root 2 over 2, plus 1/2 times root 2 over 2. So this turns into 1/2 there, minus, now inside that bracket, we're going to get negative root 2 over 4 plus root 2 over 4. And I can scarcely believe it. Negative root 2 over 2 plus positive root 2 over 2 is going to go away on us. So when all this is said and done, this whole thing is equal to 1/2 minus 0, which is 1/2. So give it a check on your check it on your calculator if you want. It should work out nice. I'm not going to take the time to do it, but it should give you a clean answer like that. Now the next one number 2, is straight to another algebraic expression. And for this one, be careful, because we're dealing with something that we looked at very briefly earlier, and it was a bit troubling, because this is going to be x plus 1 to the negative 2 dx. And the thing of it is, we don't really have a way to deal with these bracketed expressions, such as this. But because it's a chain rule that brought us to this. So if we're going to anti-differentiate, we'd have to do the reverse of the chain rule, which we don't know how to do. So you have to think with this problem that you might want to check your answer. Now you may also be thinking that when we saw these earlier, because the derivative of x plus 1 is just 1, we're in luck. It's going to work out well. Still, we want to be careful. So when we take the antiderivative of this, we would then get x plus 1, we'd add on 1, which is negative 1, and then negative 1 times 2 would give us negative 2. And this would be going from 1 to 3. So it actually goes pretty well. And then we get, in easier form, would be negative 2 over x plus 1 to the 1 from 1 to 3. So we do our substitutions. So negative 2 over 3 plus 1 minus negative 2 over 1 plus 1. So negative 2 over 4, negative 1/2, minus negative 2 divided by 2, which is negative 1. So negative 1/2 plus 1 is equal to 1/2. So this thing is equal to 1/2, just like the previous one. Check your answer on your calculator and see what you get for that. Now the next problem is just fairly redundant, like it's just another total area question. So for y equal x cubed here and to there, and I believe the answer is also equal to 1/2. It's not like everything has to be equal to 1/2. It just seems like that. If I'm wrong, please somebody let me know. But I'll stop right there. That's really a fairly good sampling of these. The next question is going to just go a little bit further with this type of problem. I don't think anything too outrageous, though. So thank you for your time.